Geography is the only weapon that doesn't need to be fired to be lethal. I'm Julian Vance, and today, we are mapping the end of Western industrial certainty. Even if unlimited AI chips could be manufactured tomorrow, they still could not all be used, because the real constraint in the AI race is no longer fabrication, it is advanced packaging. The misunderstanding. Public discussion of the global AI chip shortage typically centers on fabrication. Who can produce smaller, faster, more advanced silicon? That focus is increasingly misplaced. Today, the primary constraint emerges after chips are fabricated, during a downstream manufacturing step that receives far less attention. Advanced semiconductor packaging has become one of the most critical and most capacity-constrained choke points in the AI supply chain, the bottleneck no one planned for. Industry disclosures show a consistent pattern. Demand for advanced packaging significantly exceeds available capacity. Even with announced expansion plans, supply is not expected to fully normalize until the middle of this decade. The implication is straightforward. Advanced silicon can be fabricated at scale, but without access to advanced packaging, those chips cannot be deployed. They remain unfinished assets, not operational systems. What advanced packaging means? Advanced packaging refers to a set of manufacturing technologies, including 2.5D integration and 3D stacking, that combine multiple silicon dies into a single functional unit. Modern processors are no longer monolithic chips. They are assembled systems composed of logic dies, memory stacks, interconnect layers. These elements must be aligned and bonded with microscopic precision. This shift became unavoidable as traditional transistor scaling slowed, forcing performance gains to come from integration rather than miniaturization. Why AI systems depend on it? Modern AI and high-performance computing workloads require extremely tight coupling between processing logic and high-bandwidth memory. That level of integration is only achievable through advanced packaging. Without it, data movement slows, power consumption rises, and system-level performance collapses. Advanced packaging is not optional, it is foundational. Why failure is so costly? Advanced packaging introduces a distinct economic risk: cumulative yield loss. At this stage, manufacturers are handling known good dies, chips that have already passed testing and represent substantial sunk cost. A defect during stacking or bonding does not damage a single component. It renders the entire assembled system unusable. As a result, advanced packaging is among the most expensive and unforgiving stages in semiconductor manufacturing, where capacity is concentrated. High-end advanced packaging capacity is controlled by a limited number of firms. At the leading edge, packaging technologies used by top-tier AI accelerators remain highly centralized. Other companies provide meaningful volume, but the most advanced AI-specific packaging is concentrated among very few suppliers. Geographically, most advanced assembly, testing, and packaging capability is located in East Asia. The United States currently accounts for only a small share of global advanced packaging capacity. Why scaling is slow? Advanced packaging does not scale quickly for structural reasons. First, cleanliness. These processes require cleanroom conditions comparable to front-end chip fabrication. Second, process complexity. 3D stacking demands nanometer-level precision and careful control of thermal and mechanical stress. Third, workforce constraints. There is a global shortage of engineers with experience in advanced packaging. Fourth, materials. Critical inputs such as advanced substrates and ultra-pure dielectrics remain supply-constrained. Together, these factors prevent rapid capacity expansion. The unknowns. Several uncertainties remain. Some countries are investing heavily in domestic advanced packaging capabilities. However, publicly verifiable data on large-scale yield and reliability remains limited. In the United States, multiple facilities have been announced, but meaningful capacity additions are still years away. There is also ongoing debate over whether export controls on packaging technologies meaningfully constrain AI progress or simply redirect system design choices. These questions remain unresolved. Why governments are paying attention? Western governments increasingly treat advanced packaging as a strategic capability. Recent export control updates have expanded scrutiny over technologies related to high-performance memory integration and advanced packaging equipment. The U.S. Department of Defense has explicitly identified domestic packaging shortfalls as a supply chain vulnerability, launching targeted programs to secure mission-critical capabilities for defense systems. This reflects a broader shift in thinking. Advanced packaging is no longer a manufacturing detail. It is a strategic asset. The strategic implication. Because high-end advanced packaging capacity is geographically concentrated, the global AI ecosystem carries concentration risk. Any significant disruption affecting that capacity would ripple across data centers, cloud infrastructure, Defense electronics, financial markets. This is not a prediction. It is a structural observation. Conclusion. What can be stated with high confidence is this. Advanced packaging is a verified bottleneck in the AI supply chain. Capacity is limited, scaling is slow, and control is highly concentrated. While attention remains fixed on who can fabricate the most advanced chips, the decisive constraint has shifted to a quieter stage of production, the step that turns silicon into a functioning system. The AI race is no longer decided only where chips are made. It is increasingly decided after they are built.